Okay. Oh, shoot. Why didn't you go back? So here's our solid. And I'm going to show the edges here. So you may recall making something like this from the 193 class. We have this surface and this surface, and we connected the surfaces together by blending them, and then we joined them to make one surface. So today's lecture is going to be about analyzing existing surfaces. So if I were machining this part, the first thing I'm going to do is go, oh, of course, I can't, here it is. I've got my little cheat sheet I made for you guys on surface analysis. These are the things I do to check a surface, and I'm going to blow through it and just do a quick demo on these. And the first thing I really would do is I go to the Gaussian curvature. I used to do the dress up first, but I go right to the Gaussian curvatures, and I look for positive and negative values. So on the part, under shape morphing, under review, you have shape morphing. Where did it go? Oh, right here. Surfacic curvature analysis. Now, when you get this warning, and in your Word doc, I want you to make a picture of the warning, it's telling you exactly what to do. You have to customize your view to show material. So right there, I'm not in the show material view mode. The one that has the view material is this one here, which I find ironic because you have to view material on a surface where a surface can't have material because a surface is infinitely thin in material. So there are infinitely thin in space. So there is no material, there's no density, and yet we have to apply the shade mode with the material active in order for us to see anything. So I'm going to cancel this and activate shade with material. Now if I go to Surfacic Analysis Curvature, the first option is the Gaussian Surfaces. So when I click on this, I click on the surface. Oh, you know what? I'd already been messing with this earlier, so it worked. What you want to do is click on this first icon and then hit use min max, and it will shade the colors blue and red and yellow and green. So green is going to be my easiest, smoothest surface, and where you see the red and blue is a more aggressive transaction or transition of radiuses. Okay, so right in here it's bending more than it is right here. See how this part's kind of more flat? That's why it's green, and now I've got more curvature here, and that's why it's blue. And there's curvature here, but not as aggressive, so it's in the yellow. All right, now what I'm looking for is to be all one color. So let's say, for example, you were going to machine the outside contour of a plane where it'd be perfectly cylindrical, right? Or at least a curvature all in one direction, all one radius. I would expect the surface I'm going to machine to be green and not transition in any colors. In this case, it is going to transition, and I can machine it, and the radius values you see here in the blue and the red are your positive, negative values. Okay? I'm going to try and further describe that, but just for right now, understand that we're doing a Gaussian curvature to check a surface of a part. And what you might really do is hide the engineering part and open up the surface used to make that part. So this was the machine surface in that case, which is a joint surface. So I'm going to unhide that. And I'm going to, right now, it's on the split element. The element I want to analyze right here is this joined surface. Those were 3 surfaces to make one, and I'm analyzing that one surface right now. Again, you have these different options here to change the shading mode, how it's going to visually look. You don't have to really know a whole lot, other than you shouldn't have a bunch of different colors, unless that looks like the part is doing a lot of bending and twisting, and that's what you have. So the main one I use is this one or this one here. They seem to do pretty much the same type of thing. And then you want to hit use min max when you get that to come up, and then you'll see some colors change. Okay, so it's a quick, easy way to shade the surface and look for changing in colors. And if the colors are changing and you don't think it should change, that's where you want to go in and verify if it's okay or not. So to do that, the next step would be to do the dress up. So under dress up, I should be able to select my joined surface, and it used to allow me to change my isoparameters in the U and V direction, and I don't know how to do that anymore. I'll hit apply and say okay. What you're looking for under the dress up features is these should be kind of equally spaced, and not these ones here that come up to the sharp edges. It's those dashed ones. Okay, if they are grouped together really tight, that would tell me there's probably something weird going on in that area, but it might be hard to see on your screen. Oh boy.
But you're only looking at the dashed lines, not the solid ones?
Right, just looking for these light dashed lines that are actually on the surface. These solid ones are not actually touching the surface.
Alright.
Okay, again, I just run a quick dress up, look at the isoparams to see if they're bunched up anywhere, and then I would analyze to see, is there a reason why this is bunched up? Is there a good purpose for that? Okay, so this one here is all pretty evenly spaced. It's not looking like a bad surface at all. So I'll remove that. The next thing I might do is the porcupine curvature. And when I run a porcupine curvature on that joint analysis, okay, and by the way, you're going to do something similar. You're going to create a surface, and then you're going to run a porcupine. And these porcupines, or the red lines that you see, are all normal projections from the surface. And for tooling or for machining, what I'm seeing is that the red lines don't cross back over on top of itself. Again, if they cross over the top of itself, it's called that outer normal inverted error if they're crossing. Now this is showing me a transition from a positive to a negative value, which is okay in this case. Alright, so I don't want the red lines crossing. That would be just a quick, fast indicator that, hey, I think something might be wrong. When I try and machine this, it's going to have some challenges because this is crisscrossing in here. And it might be causing the head or the cutter to dig into the part or smack into the part with the head. So bottom line, a quick check to see what's going to happen with the NC cutter as it's going around. you want to make sure these red lines don't cross over the top of each other. So Gaussian curvature, dress up isoparameters. I'm going to skip reflection lines. It takes kind of a little bit longer time. Positive, negative values. This is why we saw the porcupines going up and down. Under the Gaussian curvature, back to this one. You see that I've got the analysis here in this tree. Okay, and I just canceled that porcupine. I guess I could say okay to keep it and have that porcupine in my tree for later. If I go back to this surfacic analysis and pick this join surface, make a note that limited is used quite a bit. So if my cutter is a 1-inch cutter, I have a 1/2 inch radius. So with a 1/2 inch radius, when I say okay, let's delete this out. I'm going to try that again. Select surfacic curvature analysis and choose limited, and then here, so again I use limited, and then for radius I'm using a 1/2 inch radius here. So a 1/2 inch radius, I can select the join surface. I like to grab it off the tree to make sure I grab everything. It's telling me that everything is greater than a 1/2 inch. That would tell me that my cutter with a 1/2 inch cutter would be no problem getting in there and machining it. Let's say I have a 2-inch cutter, so that would be a 1-inch radius, and I hit tab. I hit OK. Again, there's no real issue on a 2-inch cutter being able to machine the top of that surface. Now, double click on that. That's with a 1-inch surface. There used to be an arrow right on the top. I could click it and it would tell me, where I could invert the arrow. So if I were machining it on the other side for whatever reason, let's say this part were upside down really, and I want to machine this side of it, I could indicate that by clicking on that arrow. So I'll delete this out. I don't think I can just rotate this like this and have it machine on the top surface. I'm pretty sure it's still gonna, boy, my computer is really slow trying to rotate this thing around here. Again, I'll go to this surface, and I got a 1-inch radius. Looks like everything's still okay. There's a way to invert, and I forgot how to do it right off the bat, so I'll come back to that. There is a way to invert the arrow, so I think I'm machining the opposite side. Alright, so I'm going to go back to the top view, the ISO view. I'm analyzing the surface. Again, this is the surface that was used to split the solid. So we're all good here on the surface analysis instead of analyzing the part. If my surface is no good, then I know my solid is really not good, even though it may show colors indicating that it is okay. Alright, so these are quick checks you can do to see if everything is connecting okay, or if there's any curvature issues. Now, if I go to review, we did the porcupine, we've done surfacic curvature analysis. I don't have an example of this, but the part where you created a draft angle, you can analyze a side of a surface and find out what the angle is of that surface. Light distance, we can reflect lighting on a surface and look for lighting to show any inflections of the surface. And one of the most common ones I really use is this connect analysis. For something like this, I would use connect surface. Now if I click on this, the problem is that whole join, I don't really know. Like, you can join the surfaces and they can have issues. So I'm going to cancel that. The surfaces that I use to do the join, the only way to go check that is to check these extrude 1, 2, 3 and the extrude 1, 2 in the blend. So I'm going to hide the join surface. Boy, that's slow. Unhide the top surface. Unhide the bottom surface. This is why, guys, we don't want to. You don't hide the surface inside. You only hide the geometrical set. Otherwise, I got to double do this. So this should not be in hide. Only the geometrical set should be in hide. So there's your top surface. And I got to do the same thing here for this surface. There's your bottom surface. And the blend surface also is in hide. So we're doing twice the work here by hiding them inside. You want to only hide the geometrical set. So it looks a lot like the join, but these are three separate surfaces. Now, before you join them, you really want to check these surfaces to see if they're correct. And the fastest way to check that is using the connect checker analysis. So that's this icon down here, this feature. And I'm going to use this one here. And I'm going to check G1. Select this surface and this surface. Oh, I'm sorry. Let me do this. I'm going to highlight all three surfaces and then hit the connect to see if those three surfaces are connecting. Again, these isoparameters. Now it looks like there's a twist here. That could indicate an issue that I need to address. Also, I'm getting a minimum degree . Okay, I'm getting a minimum degree on that angle here. That's for G1, and then G2 would be the curvature check, and that says that they blend smooth. The curvature from this surface to this surface and the middle surface to the top surface are blending smoothly. G3, that angle should be for this angle here, so I'm going to go back to G1, and this should be from surface to surface. Oh, That's what I'm expecting to see. Minimum degree is 0 degrees. I must have had them all active. Anyways, the G1 here is what I'm looking for. There are two angles that are acceptable, 0 degrees and 180 degrees. So, tangent elements, lines and curves must be 0 to 180 degree angle between elements. They also must be touching, they must be adjacent. So, I check for adjacency by using G0. So if I click on G0 up here, G0 is highlighted. It's saying right here in this window, if it's within 00039 or closer, it will recognize them as adjacent. If it's 0.004 out, it will no longer represent adjacent, meaning that the elements are not touching. So again, when I grab those three surfaces, and under G0 is telling me minimum 0, I know that these boundaries of the surfaces that touch each other are indeed adjacent. So these are probably some of the most important factors when looking at your surfaces to make sure they're going to be machinable. So that's the curve connect and surface connector, which curve connect is the same thing as adjacent surfaces, and surface connector is the same thing as the tangent elements. Sorry, adjacent elements is the same thing as the check for curve connector, and tangent elements is the same thing as the surface connector check. We're checking for tangency and touching elements. And not only are our elements adjacent, but our surfaces are adjacent. So in all actuality, the curve connector that I just did and the surface connector I just did, I checked adjacent surface and a tangent surface. Okay, and these are things to make that part an NCable surface. The surfaces must be adjacent and the surfaces must be tangent. So that means that you have a 0 degree angle or a 180 degree angle. I'm going to do another demo about adjacent elements and tangent elements, NC programming, those elements being wireframe rather than the surface, and then also to define positive negative values and machinable curves. That will be in the next demo.